algebra. We have a quick question about the math packet. Go ahead, Evelyn.
Are you able to like put things to the first power and then use the equation multiplication?
Yes, if you have a 1 in the 5-card challenge, you can use that 1 as an exponent, which is super helpful. You can use the 1 as the degree of a root, which is also super helpful. So yes, the 1 is very versatile.
So like if I did one equation like 8 minus 3, that would equal 5, could I do 8 to the first minus 3? And
Yes.
Be a separate equation?
Yes. And 8 minus 3 to the first would also be a separate equation. Or 8 minus 3 in parentheses to the first would be a third equation. Yes, they're all different items. Anyway, CO14, the last of 5 rules for simplifying exponent expressions. And like we've talked about, each rule kind of has its own flavor to it, its own character. What do you notice is true about all 3 of these expressions we have in the top example section? Aiden. They all have parentheses. Okay, so to recap, if you see a multiplication symbol, you are multiplying by the same base. If you see a fraction, you are dividing by the same base. If you see a 0 power, it's the 0 power rule. Negative power rule. And here, if you see parentheses, it's what's called a power to a power. This is where we use parentheses to expand the base. We've talked about this a number of times before. Without parentheses, 3n squared, that 3 is a coefficient, right? It's not part of the power. In expanded form, it'd be 3 times n times n. Only 1, 3. But with parentheses, now this base has been expanded. The base has been expanded and said what is being squared is the entire thing. So instead of 3 times n, we have 3n times 3n, right? What parentheses do to a base is they include all that other stuff. So if we want to write this simplified, how many 3's do we have all being multiplied together? Yep. 2 of them. How do we write 3 times 3?
3 squared.
3 squared. How many n's do we have multiplied together? 2 of them, right? N times n is n squared. So the simplified form of 3n in parentheses squared is 3 squared n squared. Okay? Because remember, and we didn't define distribute yet, but if you recall from PO7, when we solved equations, what did the distributive property do? What did it accomplish? Because there were parentheses in all those equations too, right? We said when you see parentheses, you know you need to distribute. What did distributing do? It got rid of the parentheses, right? Back with equations, if it was 3 times n plus 7, and we distributed the 3 to get 3n plus 21, there are no more parentheses, and we could go on with the solving. Okay? The same thing happens here. To distribute means to get rid of the parentheses. And we're first going to look at how to do that in expanded form. I'm actually going to give you the rule today as well, rather than have you just do the first page all in expanded form, then give the rule, then do the second page. I'm going to expose the greatness early, give you the rule today. But essentially what we're doing is we're getting rid of the parentheses. So the next one, 10xy squared, all that in parentheses, cubed. Meaning, what is the base of this power of 3? What's being cubed? Evelyn? Everything, right? And cubing means something times itself. So in expanded form, what this looks like, and give yourself plenty of space here, 10xy squared times another 10xy squared times another 10xy squared. Because that's in parentheses, everything in there is being cubed. Follow me so far? Yeah. Getting this? All right. So how many 10s do we have all being multiplied together? 3. How do we write that? 10 cubed. How many x's do we have all being multiplied? 3. And how do we write that? X cubed. Now this one, be a little bit careful. How many y's do we have in total all being multiplied together?
6.
We have 6 of them.
What?
Because how many y's are in a y squared? 2. Plus another 2. Plus another 2. That makes 6 in all. Okay? If it doesn't make any sense, think about what y squared is in expanded form. 10xy squared, that y squared is a y times y. And here's another y times y. Here's a third y times y. How many y's are there? 6 in all. Okay? So sometimes, and the reason why this is called a power to a power is that if you have an exponent already in the parentheses, that exponent doesn't go away. It's part of what's being cubed. So you have to notice the difference between if it's just 110, now 3 of them, just 1x, now 3 of them, or 2 y's and 3 groups of 2, total of 6. Okay, Gus?
So would the rule be to multiply the exponent outside the parentheses?
Well, I mean, we have a rule where powers are added, right?
Yeah.
CO10. We have a rule where powers are subtracted, CO11. Perhaps there's a rule where powers are multiplied. And Gus is noticing that maybe that's the case here. He's saying, well, 3 times 2 equals 6. You know, this x really has a power of 1 on it. 3 times 1 is 3. Maybe you're onto something, Gus. We shall leave you in suspense. First time I've used that one this year. All right. Last one. We have parentheses, and inside of the parentheses is a fraction. We have the exponent on the outside here, that power of 2, which means that the entire fraction is being squared. So we have 5n squared over 4t cubed times another 5n squared over 4t cubed. Right? Whatever's inside of those parentheses, that's what the base is for that power on the outside. So, solving this, it is a fraction times a fraction, which is kind of nice because we just go straight across. How many 5s do we have all being multiplied together? 2. How do we write that? 5 squared. N to the 4th, right? Because we have n squared times another n squared. Total, that's 4 of them.
14.
And then in our denominator, not 4t, 4 squared, because there are 2 of them now, right? 4 times 4.
14.
And it's not t to the 9th, it's t to the 6th. Why is it the 6th? Because we have 3. We get 3 more. 3 plus 3 is 6. And again, going back to hold on. Going back to expanded form, once we take care of the parentheses, once we use this rule to get rid of the parentheses, now we have t cubed, which is t times t times t, times another t times t times t. How many t's are there? 6. Okay? But going back to what Gus said, you're like, well, it looks like we multiply the powers. Where do you see that connection here now? Because remember, the goal is that we don't have to write it in expanded form, right? We're doing this step here just to help us visualize what's actually going on. We don't want to have to do that every time because it can get kind of lengthy, you know? And I'm only using powers of 2 and 3. Wait till we get 5s and 10s and 20s and chance?
I think you multiply the power to the exponent.
Yeah, so the act of distributing, when this 2 got distributed into the parentheses, it became 3 squared and n squared. Right? What exponent did that n have on it inside of the parentheses? Even though it's not written, what is there? Luca? A 1. 1 times 2 equals 2. The second one, we distribute the 3 into everything in the parentheses. The 10 became 10 cubed. The x, 1 times 3, became x cubed. And Emmeline, the y, 2 times 3, became y to the 6th. So when the multiplication happens, It doesn't happen after you write it in expanded form. The powers are multiplied when you distribute the exponent in. So if we go back to the beginning here, we distribute the 2 into the 5. That became 5 squared. We distributed the 2 into the n squared. 2 times 2 is n to the 4th. There it is right there. We distribute the 2 into the 4. That became 4 squared. And we gave the 2 to the t cubed. 2 times 3. There it is right there. Okay? So this is the rule where powers are multiplied. And you get that when you have parentheses, right? Let's fill out the base, or let's fill out the rule here, okay? So you'll notice that they're a little bit different. It's not strictly coefficient, exponents, base here, because there is a difference between a coefficient base and a variable base. Because technically, both the 3 and the n are part of the base, right? But in that term, 3 is the coefficient. Technically, 10xy squared is all part of the base, but within that term, 10's the coefficient. Same thing with the 5, and same thing with the 4, right? So a coefficient base, the numerical bases, they get the power. Okay? They get the power. Meaning the 3 got the 2, became 3 squared. The 10 got the 3, became 10 cubed. The 5 got the squared. The 4 got the squared, became 5 squared and 4 squared. All right, so those numerical bases, the coefficient bases, they get the power. The exponents, they are multiplied, as we can see there. And the variable bases, do they change? Did x here change at all? The base itself?
No.
No, the power changed. X is still x. Y is still y. T is still t. N is still n. Right? So as we've seen in other rules, those variable bases, they stay the same. Okay? The variable bases stay the same. There it is, in a nutshell. Who has questions? Because I'm sure there are some. We'll go through several, for sure.
Are we just doing the first page today?
Nope, the whole thing will be homework for the weekend. Well, we got 17 minutes to do a bunch together. We can do this. We got this.
Wait, so can I do my homework and then study? Can I do like half of it and then study for a test?
Yeah, we have 100.
We have a science.
questions.
It's 100 points.
From who?
Over
Science.
It's over
So
100.
like, can we do like
It-
half
yeah,
of
It was assigned today?
Yes.
We're having it in science class.
Oh, and it's due on Monday?
No, it's a science
it's
test.
a
It's due today.
It's a test.
Oh, then why are you complaining about weekend homework?
No, I mean, like, we want to
Or you want to study? Oh.
I was gonna
We
say.
can do it wrong.
Wait, starting.
Oh, that's not it. Okay, let's look at 3n cubed. This is very similar to the first one. We did the 3n squared. You see parentheses. You know you're going to need to distribute. So that coefficient base gets the power. That becomes 3 cubed. Okay? The variable base, that n, has an exponent of 1 already. And so when you distribute the 3 into that, 3 times 1 gives us n cubed as well. Okay? In expanded form, if you want to write it out, 3n times 3n times 3n, we have 3 3's. Well, that's if I assign it justice for homework. We skipped right to the rule this time. If you were to put it out, 3 times 3 times 3 you see is 3 cubed, n times n times n you see is n cubed. Okay? You could, if you wanted to, take 3 cubed and multiply it out to be 27 n cubed as a final answer. You don't have to, but you have the option because it is a numerical base. Okay? Because 3 cubed equals 27, right? 3 times 3 times 3.
Oh.
You can't do anything with the n. That's why that base stays the same. But the reason why I didn't put that the coefficient base stays the same up in the rule is because it doesn't have to. You can change it. You can multiply it out if you want. You don't have to, but the option's there. Yeah. Okay. Next one. 2x squared y cubed to the 4th. We distribute the 4 into the coefficient. Becomes 2 to the 4th power. Distribute the 4 into the x squared. This is saying we have 4 groups of x squareds. If we have 4 groups of x squareds, how many x's are there in all?
X.
X is not a number. It's not a quantity. I mean, it is 8, right? X to the 8th. 4 groups of 2 x's is a total of 8 x's. 4 groups of 3 y's is a total of 12 y's. Okay? Why? Because if you were to put this, what? No, that's just the base. My question was 4 groups of 3 y's is a total of 12 y's. You were going for the dad joke, weren't you? You were trying to best me at that. Okay? Someone says slow down. Is that because you have questions or just? Sorry. Okay. Let's look.
I got your dad doing stuff like that, Joe.
So notice that -4 is in parentheses, which parentheses around a negative sign mean it's part of the base, right? So when we distribute in this power of 2 to that -4, -4 is actually being squared. So when we write this out, we have to make sure that we include parentheses around the negative sign. Okay? See, now you were gazing, I was watching, you were gazing over here at what was going on, you weren't listening to what I was saying, and now you've got questions, right? It's not a, okay? So when we distribute that 2 into a negative number, because the negative sign is part of the base, what's being squared is actually -4, we have to keep the parentheses around the negative sign. If we don't, remember this is different than this, right? We talked about this way back in PO9 here. -4 squared without parentheses is -16, because the negative sign is not included in the squaring. With parentheses, this is +16. Right? Remember this?
A negative
If you put -4 squared into your calculator, you're going to get a -16 because what you're telling it to do is square the 4. That negative sign acts as a coefficient. Just like in our -t to the 0. Same exact thing. Right? A negative sign that is not in parentheses is not part of the base. So because this is what we want, -4 is being squared. We need a +16 from that. We have to keep that -4 in parentheses when we write it out. Okay? And then how many n's do we have in all? 2 groups of 3, multiply the powers, n to the 6th. Yes, Aiden.
I got -64 n to the second somehow.
-64. I think you took -4 cubed. But remember, this exponent of 3 does not apply to the coefficient, only the n's. Okay? There's only one -4, but we're squaring it, so now there are 2. And a -4 times a -4 is a +16. You wouldn't then go and multiply it by -4 a second time. Okay? Other questions on that one? It just goes back to understanding the difference between a coefficient, a base, and a power. Okay? And just getting it ingrained in your head that the base of an exponent is what is directly attached to it. And a negative sign outside of parentheses is not part of the base. It's not part of the base. It acts as a coefficient. The next one here, a negative power. What? We can do this. The squared goes into the 15. That 15 takes on the power as a numerical coefficient. And when we distribute the 2 into the x to the negative second, the rule doesn't change. Multiply the powers. What's negative 2 times 2?
-4.
Negative 4. Okay? Now, this one's got one extra step in that the exponent's negative, which means it's in the wrong part of the fraction. So what do we have to do now? We move it. Right? We enact the negative power rule and say, uh-oh, that's in the wrong spot. Our final answer is going to be 15 squared over x to the positive 4th. Right? A negative exponent means it's in the wrong spot in the fraction. So we move it to the correct spot in the fraction. That's all it means. And the reason why it's negative is because the rule with a negative exponent to start with, negative 2 times 2, gives us negative 4. Okay? The next one, we end with two fractions here. Try this one on your own. It's very similar to the one you had up at the top, that third example. Try this one solo. What is this one going to simplify to be? Okay? Take a look at what we did, third example up at the top. This is very similar to it. Look at the rule, read the rule, follow the rule. You have a numerical base, variable bases. Everyone get a math packet 3 that didn't have one?
Yeah.
You did not?
Might need an extra one.
Mr. Something.
So when you distribute this 3, everything gets it. This 5 becomes a 5 cubed. It's a numerical base, a coefficient base. It takes the power, or gets the power. This x to the 4th, well, we already have 4 x's, and now we're cubing that. We're going to have 3 groups of 4. How many x's is that? 12. 4 times 3, x to the 12th. And then in our denominator, we have n cubed. We have n times n times n 3 times. So we have n cubed times another n cubed times another n cubed. How many n's are there in all? 9. And again, the rule, multiply the powers. We have 5 cubed, x to the 12th, n to the 9th.
That's you were confusing with the extra stuff.
The expanded form? Well, that's why it works, right? If you're ever asked to explain why this rule works, expanded form, you can see why. Aiden.
How'd you get 5 cubed?
Because a coefficient base, a numerical base, it just takes on whatever power is on the outside. Like we saw here, right? That 3, the reason why it became 3 cubed is because in expanded form, 3n times 3n times 3n, we have 3 3's all being multiplied together. Okay? Last one. As we get deeper into this, you will find that rules start to combine themselves. If you look at the last one, you see a negative power. You see 2 bases of n, which means that we can combine them because they're the same base, and you've got parentheses. My advice to you is to simplify within the parentheses first. It just makes the whole distribution a little bit less liney, less complicated. So tell me how we can simplify within the parentheses first. 3n to the negative 3rd over 2n squared. How can we simplify that? How can we combine those bases of n?
Oh, that's a smart.
Look at what we have. We've got a negative power going on. James?
Why not just be like n to the first, so you have to combine them?
We do have to combine them. And we have a couple different ways we can do that. It's not going to be n to the first, though.
N to the negative?
Hugo?
Would it be 3 over 2 n to the 5th?
Why is it going to be 3 over 2n to the 5th?
Because if you subtract the exponent, it's like
Wait,
the other
this?
rule.
Yeah, why is it 5 down there?
Because negative 3 minus 2 is -5, and then you put it to the other part.
So you have two options here. If you go with the rule of CO11, which is subtract the powers, you get -3 minus 2, which equals -5, right? And if you subtract the powers, -3 minus 2, that gives you 3n to the -5th over 2. But that negative power can't be negative, so we move it down to make it positive, thus 2n to the 5th. Your other option is to take care of that negative power first, move it down to the denominator, and now you have 2n squared times n to the positive third, because you moved it, so the sign changes, right? And how many n's do we have total down there? 5. Right? So either way that you do it, regardless if you use CO11 or CO13, you end up with positive 5 n's in the denominator, which makes this distribution a little bit easier now. Christopher, what's on your computer?
Excuse me for the interruption. If second grade could come down for their golden spoon prize, the rest of the school, we are adding one more golden spoon prize to our rewards, and it is a popcorn Friday. So if second graders could come on down to their popcorn, please come to the cafeteria. You're going to eat it down here, and then your teachers will
What would they do?
Of course they get it. They should have added it when they
That's a
created
scam.
That's right. We did win it first.
I know, we should get it.
We should rebel.
You should call Mrs. Napoli.
I will talk to her about that later. Okay. So we distribute the 2 now into parentheses. Makes it a little bit less liney, but our numerator, 3 gets the power. It's a numerical base. Coefficient base becomes 3 squared. The coefficient 2 in the denominator becomes 2 squared. And then our n to the 5th, we have n to the 5th times another n to the 5th, 2 groups of 5, n to the 10th. Exponents multiply. And so this would be your final answer. Okay?
one left. They just have this last one.
I have one
The second to last.
Any questions on what you've seen? Folks. Okay? Hey.
What's that number behind there? It's not the exponents.
2 squared n to the 10th. Okay. All right. The backside, second page. This is going to be your homework for Monday. They're pretty straightforward, especially the top row, right? These look very, very similar. In fact, all these first 6, you have examples of all of them virtually exactly on the front side. Okay, so if you get stuck, look back, find one that looks similar to it, either the bottom 6 or the top 3. They've all got kind of cousins there that you can look at to help you. Down here, even the third row, they're all fractions, but we had fraction examples also. Okay, the bottom row is where you're going to have to really put your thinking caps on a little bit, because I throw at you, it's all me, throw at you things like a 0 power here, negative powers here. A fraction where you can simplify bases together, okay? The bottom row is really where you start to combine rules. Because PO15, if you look ahead, all rules are in play. Look how much fun that looks. All rules are in play in PO15, okay? So this is your intro to that, all right? All of CO14 due Monday. I'm gifting you 3 minutes now to work on it. Spirit of Christmas. Sounds like science. Nothing important going on there today. So you're working on it during then, right? But due on Monday.
I just have 100.
Yeah, good thing you don't have to do expanded form. Wait till I do my outro. Questions, comments, concerns, complaints, comments, congratulations, criticisms on CO14.
I did math.
3 minutes.
All right, that's how you math.
Don't forget to